Hey everyone! In this video, we're going to walk through how to analyze data from a completely randomized design, or CRD, using SAS. First, let's take a look at a simple example of a CRD setup. Suppose we're testing 3 different fertilizers, A, B, and C, to see which one produces the highest crop yield. We apply each fertilizer to 3 randomly selected plots, giving us a total of 9 observations. So, fertilizer A is applied to plot 1, plot 2, and plot 3. Fertilizer B goes to plot 4, plot 5, and plot 6. And fertilizer C is applied to plot 7, plot 8, and plot 9. Now let's see how to analyze this in SAS. Step 1 is data entering. We begin by creating a dataset called fertilizer CRD using a data step. Inside this step, we define 2 variables. Fertilizer, which stores the type of fertilizer, A, B, or C. Yield, which records the yield in each plot. We start with the command, data, fertilizer_CRD. Then we use input, fertilizer, and yield. Since we're using letters for the fertilizer variable, we have to use the $sign to indicate that it's a character variable. The dataline section is where we manually type in our data. Each line represents a plot and shows the fertilizer used and the corresponding yield. For example, the first line A20 means fertilizer A gave a yield of 20. Likewise, we enter all the data for the 9 plots. Second step is running the ANOVA. After the data is entered, we use the PROC GLM procedure to analyze it. PROC GLM stands for General Linear Model and is used for performing ANOVA and regression in SAS. Inside this block, the line class fertilizer tells SAS that fertilizer is a categorical variable, not a numerical one. The line model yield equals fertilizer specifies the ANOVA model. We're testing if the mean yield differs depending on the type of fertilizer. Finally, the line means fertilizer/Tukey performs a Tukey's multiple comparison test, which helps us identify which specific fertilizers are significantly different from each other. Now we are done with the code. Make sure that you've placed all the semicolons correctly, as they are essential in SAS. You can now run the code by clicking on the icon of the running man in the toolbar. Once the code runs, SAS will output an ANOVA table showing the p-value for the treatment effect. If the p-value is less than 0.05, we can conclude that at least one fertilizer leads to a significantly different yield. It will also show results from Tukey's test, indicating which fertilizer pairs are significantly different. Now you can save your project by giving it a name for future use. And that's it. A complete CRD analysis in SAS.